So last week and next week, we were just focusing on polygons, how to identify what type they are, and how to solve a few questions about them, like their sides and their angles. So you should have already done the 8.5 warm-up. We're going to take some notes. Please pause the video and take notes along with the video. Then show me your notes. You can get a worksheet. And then finish up your Khan Academy for the week, and then we'll take the exit ticket. So you know the SAT formula chart looks like this. There are some formulas you're going to need to know that are not on the SAT formula chart. And that is the distance formula, which is based off of Pythagorean theorem, and the slope formula, rise over run, change of y over change of x. So grab the warm-up sheet. If you don't have it, it's okay. And I'm going to give you 4 points, and let me have you find these distances. So which formula do you use? You should be using the distance formula. So pause the video and calculate these 4 distances, just round to 2 decimal places. Okay, so in our notes, we're going to talk about quadrilaterals on the coordinate plane. The coordinate plane is the XY axis, and we're just focusing on quadrilaterals today, which are 4-sided shapes, and there's different types of quadrilaterals. The first thing we're going to calculate is the length of the sides and the diagonals, and again, that's using the distance formula. If we find out that the distances are the same length, we call those congruent lengths, and that's what we care about. So if we have a 4-sided shape and it has one set of congruent sides, it could be an isosceles trapezoid. It could also be a trapezium. If it has 2 sets of congruent sides, it could be only a kite, a parallelogram, or a rectangle. And if all the sides are congruent, then it could be a square or a rhombus. So let's look at our problem now. Sometimes it might help to visualize these points. So grab the little note catcher, and I just plotted points A, B, C, and D, and I'm going to connect them. And hopefully you know what that shape is, but our goal today is to prove what that shape is. So for our warm-up, remember we calculated the length of AB, and you should have gotten about 3.61. And then we calculated the length of BC, and you should have gotten about 3.61. And then we calculated CD and AD. And hopefully you finished all of that already, but if not, pause the video and do those calculations. Okay, so now we finished that, and you should notice that you have 2 sets of congruent sides, 2 different numbers. So it's either going to be a kite, a parallelogram, or a rectangle. So let's jot down our thoughts. We have 2 sets of congruent sides. So it could be a kite, a parallelogram, or a rectangle. Again, you should know just by looking at the picture what you have, but we're trying to prove it. So if it is a rectangle, then we know talking about just the distances right now, if it's a rectangle, then we know that the diagonals are congruent. The diagonals are also congruent if it were an isosceles trapezoid or a square, but I know it's not going to be either of those. It's only one of these 3 shapes. So I'm just going to prove whether or not it is or is not a rectangle, and hopefully we know it is not a rectangle just by looking at it. So when I find the lengths of my diagonals are the segments that go, they're the imaginary segments that go through the shape. So AC is a diagonal and B is a diagonal. So pause the video and find those lengths. Okay, well you should have found that AC was 4 and BC was 7. Since it's horizontal, you actually can just count. You don't need to use the distance formula. Since it's a vertical, you can just count. So 4 and 7, they are not congruent, so it cannot be a rectangle. So diagonals are not congruent, not a rectangle. These shapes, the diagonals are also not congruent. So now to prove that it's one of these 2, we need to look at the slopes of the sides. So how do you find slope? It's either rise over run if you have a graph, but let's use y2 minus y1 over x2 minus x1 so that you don't accidentally forget the negative and the positive signs. I get those confused. If they have the same slope, that means they're parallel. And to remember, if they have opposite reciprocal slopes, that means they're perpendicular. So if I have two numbers that are the same number, they're parallel. If I have like 1/2 and -2/1 or -2, then those are going to be perpendicular. Scoot that up. Again, pause the video if you're taking notes. If it has 0 sets of parallel sides, remember that's a kite or a trapezium. If it has 1 set of parallel sides, it can be any type of trapezoid. And if it has 2 sets of parallel sides, then it can be a parallelogram, a rectangle, a square, or a rhombus. And we're trying to identify the most specific name for this shape. If it has a set of perpendicular sides, then it could be a right trapezoid. That's like, you know, it needs 2 right angles. If it has all perpendicular sides, then it can be a rectangle or a square. There. Sorry, that was bugging me. So if some of the sides are perpendicular, it could be a right trapezoid. It could be a kite also. But if all the sides are perpendicular with each other, then it can be a rectangle or a square. So we also can look at the diagonals. Remember we went over that 1/2 D1, D2 formula. If the diagonals are perpendicular, then it is a kite, a rhombus, or a square. So even though you already have this somewhere in your notes, again, pause the video and summarize it on this 1-pager, because this is the order I want y'all to go through when you're proving what these shapes are, what these quadrilaterals are. Okay, so let's find the slope. Same thing, this is like the far right column. The slope is y2 minus y1 over x2 minus x1. So for AB, you should have gotten a slope of 4 minus 1 over 3 minus 1, which is 3/2. For BC, you should have gotten, let's see, -3/2. So just finish all of those, and then when you finish all of those, you'll realize that, hey, I have 0 sets of parallel sides. I also have perpendicular diagonals, and once you finish up that whole slope column, and we did this in class, but you'll realize those 2 things. So what shape could it be? It's got to be a kite. So we know it's a kite. So make sure you list what we know. These are the proof. This is the proof for, this is the proof for why it is a kite and not a parallelogram, rectangle, or any other shape. So you prove it by showing that you calculated these distances. Don't just put the length of the distance. Show me how you calculated the slope. And then as you do each little chunk at a time, list what you know. You can write down all the shapes and then slowly eliminate them. But they should all of your facts about the lengths of the sides and diagonals, the slopes of the sides and diagonals, should all match up to one singular, very specific shape type. So grab some tape and tape in your little example, and then show me your notes, and then you'll get a worksheet, and then we'll spend about 5-10 minutes on that, and then your exit ticket.